Good morning, students. Am I audible? Hello, students. Am I audible to you all?
Yes, sir.
Yeah. Okay. Kindly give the confirmation when I ask the questions at least. No? Yeah. Okay. So I hope you remember what we discussed in the previous class. We will quickly revise what we require in today's class. Okay. This is a symbol of a diode. Correct? This is P side and this is N side. And we have discussed two types of biasing. One is known as a forward bias, other one is known as reverse bias. So what we do in forward bias, we connect P side to the positive and we connect N side to the negative of the supply. You're clear? So such biasing is known as a forward biasing. And we have studied the forward characteristics like this. If you plot the graph of current versus voltage, the graph will be like this. Anyone remember what this voltage is known as? Yeah, anybody? What this voltage is known as? अगर बोलने में दिक्कत है तो मैसेज कीजिए. Yes, okay, knee voltage. Okay, very good. That voltage is known as knee voltage. Okay, or there is one more name given to this voltage. This is also known as the turn on voltage. This voltage is also known as what? Turn on voltage. Anyone remember what is the value of knee voltage or turn on voltage for silicon and germanium? Yes, anyone? For germanium, the value is 0.3 volt, and for silicon the value is 0.7 volt. इसका मतलब ये हुआ कि जर्मेनियम को जब आप 0.3 वोल्ट से ज़्यादा वोल्टेज दोगे देन ओनली यू गेट द करंट, एंड इन केस ऑफ सिलिकॉन जब आप 0.7 से ज़्यादा वोल्टेज दोगे देन ओनली यू गेट द करंट. आर यू क्लियर विद दिस कॉन्सेप्ट? Now what happens in reverse bias, will connect P side to the negative and will connect N side to the positive of the supply. So this is minus and this is plus. Okay, and this biasing is known as reverse bias. And if you plot the reverse characteristic, okay, that means this is a reverse voltage minus V and this is the reverse current minus I. Okay, in what happens exactly in reverse bias, practically the current is almost zero. But after a certain voltage, the current drastically increases. Anyone remember what that voltage is known as? Anyone?
Breakdown voltage.
Very good. Okay, this is known as a breakdown voltage. So what exactly happens at breakdown voltage? If you remember, inside there is a barrier region. So this barrier region will collapse, due to which electrons and holes can migrate wherever they want easily. And that's the reason the current is increasing abruptly. Are you clear? Okay, so this is about the forward biasing and the reverse biasing. Then I explained you about the transformer also. There are two types of transformers, step up and step down. Okay, now tell me, if you want to increase the voltage, what type of transformer we should use? I want to increase the voltage. Then
Step up.
very good. Okay. And if I want to decrease the voltage, then
Step down.
step down. Okay, very good. Now tell me one thing. Previously in your houses also, you must have seen there were cylindrical tube lights which are gas filled, correct? But now those tube lights are replaced by LED pattern. Okay, why LED is preferred over the traditional bulbs? What is the major advantage of LED over the traditional lamps? Anyone? Don't know?
Power.
The very first thing, they require very low voltage for their operation. They require very low voltage for their operation. Now what is the formula for power? Power is voltage into current. If voltage is reduced, then the power will also reduce. मतलब पावर कंजम्पशन जो है ना वो बहुत कम होगा, और अगर पावर कंजम्पशन कम है तो आपके इलेक्ट्रिसिटी का बिल जो है ना वो भी कम आएगा. You are getting? So they are power efficient. दे रिक्वायर वेरी लो वोल्टेज. देखो ना कितना वोल्टेज है. जर्मेनियम को 0.3 चाहिए, सिलिकॉन को 0.7 चाहिए. So these operating voltages are very low, and that's the reason nowadays LED is preferred over the traditional lamps. Okay, traditional lamps are outdated. Everyone is using LED lamps. Are you all clear with this, students? Okay, you must have heard about television screen में you get two options, QLED करके and OLED करके. Have you heard these two terms, students?
Yes, sir.
At least type करो. Okay, stay interactive. Don't just blindly listen. Okay. Now tell me, students, what is the difference between QLED and OLED? दोनों में क्या फर्क है? That Q stands for what? Anyone know? That Q stands for quantum LED and O stands for organic LEDs. Are you clear? Okay, quantum LEDs are more bright as compared to OLED. Okay, but see, previously we had CRT display. अगर पुराने ज़माने के आपने टेलीविजन्स घर में देखे होंगे, ओके, तो ये टेलीविजन की स्क्रीन है और उसका जो बैक साइड होता था ना वो इतना बड़ा होता था. हैव यू सीन दैट, स्टूडेंट? तो इसके अंदर देयर इज अ CRT, कैथोड रे ट्यूब, विच वाज ह्यूज. ओके, जिसको टर्न ऑन में ज़्यादा वोल्टेज लगता था, इसलिए जैसे ही आप टेलीविजन ऑन करते थे इमीडिएटली यहाँ पे डिस्प्ले नहीं आता था. Okay, but now these displays are replaced by what? They are replaced by LED displays. You are getting, and in LED also you get many options, QLED, OLEDs and so on. Okay, they give very nice vibrant colors as compared to CRT display. Secondly, they are power efficient because they require very low voltage for their operation. Okay, so this is about QLEDs and OLED. Last lecture I also explained you that if required we can convert alternating signal to a direct signal. Now student, tell me what is the major difference between AC and DC? What is the difference between AC
The
and DC?
frequency.
AC will have
DC
certain
has
frequency, okay, non-zero frequency, but DC will have zero frequency. Okay, so signal having zero frequency is known as DC, and signal having certain frequency is known as AC. Are you clear? Okay, so if you want to convert AC to DC, okay, that is known as rectification. That process is known as what? Rectification. And who will perform this operation? Rectifier. Okay, so for that purpose we require a rectifier circuit. Yaad rakhna. For that purpose we require a rectifier circuit. Are you clear? So there are three types of rectifiers. Remember, there are three types of rectifiers. Anyone know what are the three types? Students, anyone know what are the
Half
three types?
wave, full wave, bridge.
Very good. Half wave rectifier. And secondly, we have full wave rectifier. And the third one is the bridge rectifier. Are you clear? So we have three types of rectifier. Now, practically, we will use bridge rectifier because bridge rectifier will have both half wave also as well as full wave also. मैंने कहा था कि अभी दिवाली क्रिसमस में आप जो लाइटिंग्स लगाते हैं, ओके, उसके अंदर आपको एक जो बॉक्स मिलता है, रेक्टेंगुलर बॉक्स along with the button. Inside that you will find this bridge rectifier. Okay, so bridge rectifier is not included in your syllabus, but keep in mind that bridge rectifier can be used as a half wave also, and it can be used as a full wave also. Are you clear? Okay, so let us discuss half wave rectifier. We will go in steps and try to understand the meaning of each and every component. Okay, now tell me, आपके घरों में जो सप्लाई आता है वो AC है या DC है? The supply in your house is AC or DC?
AC.
हाँ,
AC.
it is AC.
AC.
क्या condition है उसका? You get 230 volt and 50 hertz. In India, the frequency of AC is 50 hertz. Okay, so my LED don't require 230 volt, na? My LED require a lower voltage, lower than this. Okay, so tell me, I want to reduce the voltage, na? So what should I do?
Step down transformer.
What I can do, I can use a step down transformer. So see, this is AC signal. This is a symbol of AC. Okay, and this AC is given at the input. So this is AC input, which is connected to what? It is connected to the primary of a transformer. You are getting now, since I require a low voltage, na, so I will use a step down transformer. You can see that number of turns in primary are N1, which is greater than number of turns in secondary. Okay, the examiner will check your diagram and will decide your level of understanding. Okay, what these two vertical lines indicate? Anyone know what these two vertical lines indicate? One, this is
Or
insulation. No, these are insulating plates. Okay, ये जो दो vertical lines है ना, they indicate the insulation between primary and secondary. Are you clear? Okay. Now what I will do, I will simply connect diode over here. So this is a diode. Secondary का ये S1 terminal है, which is connected to the P side of a diode. Okay, and this is the N side of a diode. So it's a very simple circuit diagram. Okay, what is the meaning of a load resistor? Load resistor का meaning क्या होता है? Any device जिसके अक्रॉस हम आउटपुट लेंगे. Okay, so this is a device across which I will take the output. Okay, and that device is known as a load resistor. याद रखना. Okay, जहाँ पे भी connection हो वहाँ पे आपको highlight करना है. These are the latest sign conventions, so keep in mind. अगर आपने ये highlighted circles किए, इसका मतलब wires are connected over there. Okay, and we will take the output across this load resistor. So this is the output which is taken across the load resistor. Okay, student, are you all clear with the circuit diagram? Okay, this is the diode D. Any difficulty in the drawing? So first we will start with AC input, which is given to the primary of a transformer. Okay, then this is secondary of a transformer. What type of transformer we are using? We are using a step down transformer. What is the reason? The reason is we require very low voltage for the operation of LED. अगर आप सीधा 230 दोगे ना इसको तो एलईडी पूरा उड़ जाएगा. इसीलिए जब आप वो लाइटिंग खरीदते हैं तो उसके साथ आपको ड्राइवर अलग से परचेस करना होता है. तो उस ड्राइवर के अंदर ट्रांसफार्मर लगा हुआ है जो वोल्टेज को रिड्यूस करेगा टू द डिजायर्ड. The S1 is connected to the P side of diode. The N side of diode is connected to the load resistor. और यूजुअली यहाँ पे ना अर्थिंग किया जाता है. What is the significance of earthing? Students, what is the significance of earthing? Anyone know? Students, have you seen the three pins? Three pins देखे होंगे आप लोगों ने. So three pins are, they look like this. Okay, this will be a positive terminal. This will be a negative terminal. What about this bigger one? You will find one bigger knob over here. What is this? This is your neutral, which is stands for what? Earthing. Okay, have you ever observed the length of these three? आपके घर में अगर एसी या रेफ्रिजरेटर का प्लग रहेगा ना उसको आज निकाल के देखना. ओके, अर्थिंग की जो लेंथ होती है ना इस रॉड की, दीज आर द थ्री रॉड्स. तो अर्थिंग की लेंथ जो है ना वो पॉजिटिव और नेगेटिव से ज्यादा होती है. उसका रीजन क्या है कि सॉकेट में जब आप इसे प्लेस करोगे ना, दिस इज अ सॉकेट लेट, 3 पिन वाला सॉकेट है. तो जब आप ये सॉकेट के अंदर प्लेस करोगे, विच पिन गेट्स कनेक्टेड फर्स्ट? अर्थिंग. विच पिन गेट्स कनेक्टेड फर्स्ट? अर्थिंग. ताकि अगर कुछ लीकेज करंट हो तो आपका डिवाइस जो है उसको कुछ हार्म ना हो. You are getting, and later on positive and negative will be connected in the network. Are you all clear? Students, are you all clear with it? Yes or no?
Yes, sir.
yes,
Pakka?
sir.
So you should know the practical applications also. Don't just learn the theory. Okay, you should know how these components are used in your real life. Okay, and you keeps on observing the different things. Okay, so now once the lecture get over na, just pull out this 3 pin and just check कि पॉजिटिव एंड नेगेटिव की लेंथ कम होगी एज कंपेयर टू अर्थिंग. और उसका रीजन क्या है कि व्हेन यू इंसर्टेड इनसाइड दिस सॉकेट, अर्थिंग गेट्स कनेक्टेड फर्स्ट. ओके, नाउ लेट अस discuss the waveform. This is the time axis. Let me draw the input. See, the input is like this. What is the nature of the input? The nature of the input is AC. So this one is AC input. This one is AC input. Okay, and let's learn what will be the nature of the output with respect to time. Okay, AC में अगर आप इनपुट पे गौर करो तो देर आर टू इनपुट साइकिल. दिस इज द पॉजिटिव हाफ साइकिल एंड दिस वन इज नेगेटिव हाफ साइकिल. अब देखते हैं कि पॉजिटिव हाफ साइकिल में क्या होगा. सॉरी, ड्यूरिंग द पॉजिटिव हाफ साइकिल P become positive and N become negative. Now tell me, if P is positive and N is negative, then the diode is forward bias or reverse bias? Students, P positive and N negative, then the diode is forward bias or reverse bias?
Forward.
So forward में we get good current or a bad current? मतलब ज्यादा करंट मिलेगा या करंट मिलेगा ही नहीं? Students, tell me, you get a good amount of current in which bias? Forward bias or reverse bias? Huh?
After the knee, you will get increase in voltage.
You get a good amount of current, na? Okay, that means the current will flow through the load resistor. अब यहाँ पे आपने कोई भी डिवाइस लगाया है, अगर उस डिवाइस से करंट फ्लो होता है तो यू गेट सर्टन आउटपुट वोल्टेज ना. यू आर गेटिंग, दैट मीन्स आई विल गेट सम आउटपुट वोल्टेज ड्यूरिंग द पॉजिटिव हाफ साइकिल. आई विल गेट सम आउटपुट वोल्टेज ड्यूरिंग द पॉजिटिव हाफ साइकिल. आया समझ में? स्टूडेंट्स, आर यू ऑल क्लियर विद द पॉजिटिव हाफ साइकिल वर्किंग? Now let us discuss what will happen during the negative half cycle. During the negative half cycle, P becomes minus and N becomes plus. You know the characteristic of AC ना? AC में क्या होता है देखो, अब आप सोचोगे ऐसा क्यों हुआ, तो देखो इसमें दो हाफ साइकिल है. तो सपोज पॉजिटिव हाफ साइकिल में करंट वाज फ्लोइंग क्लॉकवाइज ना, तो नेगेटिव हाफ साइकिल में करंट फ्लोज एंटी क्लॉकवाइज. सो इन एवरी साइकिल द डायरेक्शन ऑफ करंट या वोल्टेज चेंजेस, अपने आप बदलता है. इसीलिए पॉजिटिव हाफ साइकिल में P पॉजिटिव एंड नेगेटिव, और नेगेटिव हाफ साइकिल में उल्टा होगा, P बिकम नेगेटिव एंड बिकम पॉजिटिव. नाउ टेल मी स्टूडेंट, दिस इज फॉरवर्ड बायसिंग और रिवर्स बायसिंग?
Reverse.
दिस इज रिवर्स बायसिंग. डू वी गेट एनी करंट इन रिवर्स बायसिंग? डू वी गेट एनी करंट इन रिवर्स बायसिंग?
No.
स्टूडेंट, रिवर्स बायस में कोई करंट मिलता है नहीं. इसका मतलब डायोड वोंट कंडक्ट एंड यू वोंट गेट एनी आउटपुट ड्यूरिंग द रिवर्स बायस. Okay, now what will happen next? Again the diode will become forward bias. Diode फिर से forward bias होगा and you again get the output voltage. What happens during the next half cycle? Diode gets reverse bias. You won't get any output. Is this clear? Okay. Now tell me, what is the difference between your input and output? Can you see any difference between the two? The input was fluctuating on both the side. देखो positive side भी fluctuate हो रहा था और negative side भी fluctuate हो रहा था. लेकिन जो आउटपुट है वो एक ही साइड फ्लक्चुएट हो रहा है. मतलब जो बाई डायरेक्शनल था उसको हमने यूनि डायरेक्शनल में कन्वर्ट कर दिया. ओके, लेकिन इसमें एक दिक्कत है, सिर्फ आधा साइकिल रेक्टिफाई हुआ है, आधा साइकिल रेक्टिफाई नहीं हुआ है. सो ओनली हाफ साइकिल इज रेक्टिफाइड, हेंस इट इज नोन एज हाफ वेव रेक्टिफायर. आर यू ऑल क्लियर? सिर्फ आधा साइकिल रेक्टिफाई हुआ है, हेंस इट इज नोन एज व्हाट? हाफ वेव रेक्टिफायर. Is this clear everyone? So this one is known as half wave rectifier output. This one is known as what everyone? Half wave rectifier output. Are you all clear?
So in the negative half cycle, no current will only flow. So won't there be like a break in the circuit or something?
Sorry, repeat the question, say loudly. During the negative half cycle.
In the negative half cycle, it becomes flat, right? It gets rectified. But won't there be no current also, because like,
so there is no current, then we are not getting any output. For example, if I am connecting any bulb over here ना, RL पे अगर मैंने बल्ब लगाया तो पॉजिटिव हाफ साइकिल में that bulb will turn on, but negative half cycle में that bulb will be off only. You are getting? Okay, so
it is off only. I thought there was current somehow.
Just a minute. Let's say the time period of the input is 10 minutes. Okay, for 5 minutes the output bulb will glow, and for the next 5 minutes the output bulb will be off. Again in the next 5 minutes the bulb will be on, in the next 5 minutes the bulb will be off. This will happen automatically once you are connecting this network. You are getting? It is very similar to your street lamps कहो या फिर आपके traffic signals कहो. Okay, have you seen nowadays there are digital signals, counter के साथ आते हैं. Have you seen that? For example, the red bulb will glow for 60 seconds. Students, you know that? And after 60 seconds, the swapping will take place. Okay, this will go off and the green one will go on. So that happen after regular interval or a fixed interval of time. Okay, आपके दिवाली में भी अभी जो आपने लाइटिंग्स लगाए हैं उसमें एक पैटर्न ऐसे होता है जहां पे फॉर सर्टेन टाइम ऑल द एलईडीज विल ग्लो एंड देन all the LEDs goes off. Again after fixed interval, all the LEDs will glow, and again those LEDs goes off. Okay, that means you are connecting all the LEDs in which manner? Half wave rectification manner. Are you all clear?
Yes, sir.
Okay. Any more? Any difficulty in this? Students, any difficulty? Say at least yes or no, then I'll move ahead.
No, sir.
No, no,
No,
okay.
sir.
I have one doubt. Okay, I hope you are clear that why it is known as a half wave rectifier. But when I look at the output of rectifier, na, I can see certain peaks into it. या फिर ये स्पीड ब्रेकर जैसे शेप मुझे दिखाई दे रहा है. लेकिन मैंने जो लर्न किया है उसमें डीसी के लिए आई शुड गेट अ फ्लैट लाइन ना. But I am not getting any flat line at the output. So how we can say that AC is converted to DC? Are you all clear with my question, students? If I look at the output waveform, na, I can see these speed breakers like structure, bump in the net wave, okay? But for DC, I should get a flat straight line, na, which I'm not getting here. So can we say that AC is converted to DC? Students, will it be correct to say that AC is converted to DC?
So current is flowing in a single direction, so maybe we can say that it's DC.
But what is my aim? My aim is to get pure DC, no? And for that, it should flow only, sorry, for that I should get a straight line. Correct, na? क्योंकि DC के पास frequency क्या होती है? 0. Okay, so which I am not getting. Last lecture I explained you the concept of RMS. Do you remember? What is the formula for ERMS? Student, tell me, what is the formula for ERMS?
E naught by root 2.
It is E naught divided by root 2, which you can also write. The reciprocal of root 2 क्या है? 0.707 times E naught, which you can also write 70.7% of E naught. आया समझ में? तो इसको अगर ग्राफिकली समझना है तो ये हमारा टाइम एक्सिस है. इस पे हमने ये ड्रॉ किया एसी वेव. ओके, ये जो हाईएस्ट वैल्यू है उसे क्या कहा जाता है? पीक वैल्यू. अब इस एसी के ऊपर हम 70.7% मतलब समवेयर यहाँ पे आएगा, एक फ्लैट लाइन ड्रॉ करेंगे एंड दैट फ्लैट लाइन इज नोन एज इट्स आरएमएस वैल्यू. अब देखो आरएमएस वैल्यू के लिए हमें एक स्ट्रेट लाइन मिली है. अगर ये स्ट्रेट लाइन है मतलब ये कौन सा कंपोनेंट है? डीसी का कंपोनेंट. समझ में आया? तो बिल्कुल वैसे ही हमारा जो हाफ वेव रेक्टिफायर का आउटपुट है लाइक दिस, उसमें भी हमें एक डीसी लाइन ड्रॉ करनी होगी. ओके, समथिंग नोन एज आरएमएस वैल्यू, एंड दैट आरएमएस वैल्यू विल गिव्स यू डीसी. ओके, अब इसमें और एक बात याद रखना कि यहाँ पे जो आउटपुट मिलेगा ना, देखो हमने इनपुट कौन सा दिया था? एसी. आउटपुट कौन सा चाहिए मुझे? 100% प्योर डीसी. व्हाट आई वांट 100% प्योर डीसी आउटपुट. लेकिन वैसे नहीं होता. जो हमें एक्चुअल आउटपुट मिलेगा ना विल बी अ कॉम्बिनेशन ऑफ एसी एंड डीसी. प्रैक्टिकली बात कर रहा हूँ. जो हम थियरी पे पढ़ते हैं ना, दीज आर ऑल आइडियल कंडीशन. सो आई वांट ideally 100% pure DC. That is my ideal requirement. But practically what I will receive? I will receive a combination of AC and DC. Okay, so tell me बच्चों, output में unwanted component कौन सा होगा? What will be the unwanted component in the output?
AC.
Student, output में
AC.
AC. Okay, ये unwanted component है. And that unwanted component is known as ripple. What that unwanted component is known as? It is known as ripple. Are you all clear with the meaning of ripple? Students, are you clear with the meaning of
Yes,
ripple?
sir.
Ripple क्या होता है? In
The AC component.
rectifier output, we get some AC component along with the DC. That unwanted AC component is known as what? Tell me, student, that unwanted AC component is known as what? Ripple. Are you all clear? Okay, how to calculate the ripple, that I will explain you. But I hope you are all clear with the explanation of half wave rectifier. Any difficulty? Students, is there any difficulty in half wave rectifier operation?
No, sir.
No? Very good. So shall we move on to the next one, full wave rectifier? Okay. Tell me, student, before I start with full wave rectifier, what is the drawback of half wave rectifier? हमने AC को DC में कन्वर्ट तो कर दिया ना, लेकिन क्या हुआ, यहाँ पे सिर्फ 50% एफिशिएंसी के साथ आउटपुट मिला है. दैट मीन्स ओनली हाफ साइकिल इज रेक्टिफाइड. सिर्फ आधा साइकिल रेक्टिफाई हुआ है, रिमेनिंग हाफ इज नॉट रेक्टिफाइड. सो कैन यू टेल मी व्हाट विल बी द सॉल्यूशन फॉर दिस? स्टूडेंट्स, व्हाट कैन बी द सॉल्यूशन? अगर एक से काम नहीं बनता तो आप दो जन को लेके आते हो.
Put two.
स्टूडेंट, यस और नो? अगर एक से काम नहीं बनता तो दो जन को लेके आओ. बिल्कुल वैसे ही इस डायोड का इशू क्या है? द इशू विद द डायोड इज कि दिस डायोड इज नॉट कंडक्टिंग ड्यूरिंग द नेगेटिव हाफ साइकिल. ओके, तो मान लो अगर मुझे नेगेटिव हाफ साइकिल में भी ऑपरेशन चाहिए तो व्हाट आई कैन डू? कंबाइन टू आउटपुट? नो प्रथम. Okay, combine two output is not the solution. Okay, what you have to do, you have to use two diodes instead of one. You have to use two diodes instead of one. Okay, so let's learn again how to draw the circuit diagram for this. Okay, so my aim is to discuss full wave rectification, FWR. Okay, सबसे पहले क्या ड्रॉ करोगे? तो सबसे पहले हमें ड्रॉ करना है प्राइमरी ऑफ अ ट्रांसफॉर्मर. डोंट बाय हार्ट द सर्किट डायग्राम्स. Majority of the student do that. Understand and try to draw this. तो सबसे पहले मैंने क्या ड्रॉ किया? I am drawing the primary of a transformer. Let me call this as P1 and this as P2. Okay, इस प्राइमरी के अक्रॉस मैं किसे कनेक्ट करूंगा? Tell me student, इस प्राइमरी के अक्रॉस किसे कनेक्ट करना है? AC या DC?
AC supply.
वेरी गुड, वेरी गुड. हमारे घरों में जो AC सप्लाई है उसके स्पेसिफिकेशंस क्या है?
30 volts, 50 hertz.
And 50 hertz. These are the specification in India. Huh? If you change the country, then this specification may change. Is this clear everyone? Okay, इसीलिए जो gadgets या devices बनाए जाते हैं ना, they are country specific. Okay, मतलब अगर कोई एक मोबाइल कंपनी है, फॉर एग्जांपल सैमसंग है या फिर MI है, तो MI का मेन सेंटर जो है इट इज चाइना. You are getting, but they will design the different units for India. क्योंकि इंडिया की ऑपरेटिंग फ्रीक्वेंसी 50 हर्ट्ज है. In different countries, the operating frequencies are different. Are you all clear, students? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now tell me what to draw next. What to draw next?
Secondary of the transformer.
Secondary. Very good. Okay, we will go in steps. While drawing, 2 points you have to remember. There has to be some separation between the 2 points. Secondly, you are supposed to draw these 2 vertical lines. What these vertical lines indicate?
Insulation.
Very good. Insulation. Are you clear? Okay. These are the secondary terms S1 and S2. Another important point. Few students draw the 2 points like this. मतलब primary को ऐसे draw करेंगे और secondary को ऐसे draw करेंगे. This is wrong way. कुछ student ऐसे draw करते हैं. Primary और फिर secondary. Okay, this is also wrong way. Their faces must be in opposite direction. Their faces must be in opposite direction. Be careful. Are you all clear with this way of drawing the coil of a transformer? Yes. फिर देखो S1 को मैंने join किया the P side of first diode और S2 को हमने join किया with the P side of second diode. Are you all getting? S1 को किसके साथ join किया हमने? P of first diode और S2 को किसके साथ ज्वाइन किया है हमने? P of second diode. और दोनों डायोड्स के जो एन टर्मिनल्स है, दोनों डायोड्स के जो एन टर्मिनल्स है उनको कंबाइन करो. ओके, सी केयरफुली हाउ आई एम ड्राइंग द सर्किट डायग्राम. दिस डायग्राम इज क्वाइट डिफरेंट इन योर टेक्स्ट बुक. बट यू कैन ड्रॉ इन दिस वे, इट्स क्वाइट इजी टू रिमेम्बर। देखो दोनों के n को हमने ज्वाइन कर दिया। अब क्या करना है आगे, हमें लोड रेजिस्टेंस को कनेक्ट करना है। तो यहां से एक कॉमन टर्मिनल लिया, मतलब ये टर्मिनल इज कनेक्टेड टू द n ऑफ फर्स्ट डायोड दैट इज D1 as well as n of second diode that is D2। you are getting okay। ये देखो सेकेंडरी का मैंने सेंटर सिलेक्ट किया and now I am drawing a load resistor। now what we are drawing the load resistor। अब अगर आप देखो तो ये पॉइंट मैंने सेकेंडरी के सेंटर में ज्वाइन किया है, इसे कहा जाता है सेंटर टैप। क्या कहते हैं बच्चों इसे? दिस इज नोन एज सेंटर टैप। एनीवन नो द फंक्शन ऑफ सेंटर टैप? Students, do you know the function of center tap? What is the function of a transformer? I told you in the last lecture. What is the function of a transformer? Transformers are used for what?
Adjust the voltage.
No, it transfer the power. Transformer, na? So if you split the word transformer, transfer of power. तो पावर इज गेटिंग ट्रांसफर्ड फ्रॉम प्राइमरी टू सेकेंडरी। तो देखो प्रीवियस डायग्राम में मान लो यहाँ पे 10 वॉट्स का मैंने पावर दिया था, तो ये पूरा का पूरा 10 वॉट्स यहाँ पे आ जाएगा, क्योंकि इस पावर को यूटिलाइज करने वाला सिर्फ एक ही डायोड था। लेकिन ये वाले केस में फुल वेव रेक्टिफायर में अगर यहाँ पे मैं 10 वॉट्स की पावर देता हूँ, तो सेकेंडरी पे दैट पावर गेट डिवाइडेड इनटू 2 पार्ट्स। अपर वाला डायोड विल रिसीव 5 वॉट एंड लोअर वाला डायोड विल रिसीव 5 वॉट, क्योंकि यहाँ पे देयर आर 2 डायोड्स who needs the power supply for their operation। Are you all clear? Students, are you all clear?
Yes, sir.
Okay, any difficulty in the operation of center tap? And RL is the one जिसके across we will take the output। RL is the one जिसके across I will take the output। Okay, this diagram is quite different in your textbook, but you remember like this। This is a simple way to remember। Okay, ये समझ में आ रहा है आपको how to draw the circuit diagram? Students,
Yes, sir.
okay, so don't by heart, okay, learn how to draw it, then you will understand electronics very easily, okay। And in your board exam or in your entrance examination, okay, in your entrance examination the 40% weightage is given for electronics section, okay। So you should know each and every component in a well manner, okay। Now let me draw the waveform for this। तो सबसे पहले हम क्या ड्रॉ करेंगे? सबसे पहले हम ड्रॉ करेंगे इनपुट वेवफॉर्म। व्हाट इज द नेचर ऑफ द इनपुट? द इनपुट इज AC in nature। दिस इज पॉजिटिव हाफ साइकिल, दिस इज नेगेटिव हाफ साइकिल। पॉजिटिव हाफ साइकिल, दिस इज नेगेटिव हाफ साइकिल। Okay, so polarities are changing with respect to time। Polarities are changing with respect to what? Time। Okay, so let's learn what will be the nature of the output। okay, let's discuss what happens during the positive half cycle। okay, देखते हैं कि positive half cycle में क्या होगा। see during the positive half cycle ना, this becomes positive and this gets negative, और यहाँ पे रिवर्स होगा, this gets negative and this gets positive। so tell me student, which diode will conduct D1 or D2? which is forward bias and which is reverse bias?